Hello everyone, welcome back. This is Calculus 2. In this video, we are going to learn the new chapter 2 and especially 2.1 areas between curves. So a little bit of background in this topic. So far, we developed the concept of definite integral to calculate the area below the function by utilizing the integral symbol. So for example, so far in chapter 1 and 3, let's say we have a function f of x, and then we have to find out the area a to b, and then by using the integral symbol, we were able to find out the area under the curve. In this topic, what's happening? What if we have a little bit complicated region? For example, let's say I do have a 2 function, okay? So that I want to find out the area between those 2 functions. So how would you be able to find out this area between 2 functions? Okay, so that's a different thing. In this chapter, we are going to deal with 2 different functions and going to find out the area between curves. Does it make sense? So that's a different thing from the previous chapter. A little bit, we're gonna expand the idea to calculate the area between 2 curves. So it's gonna be very similar what we have done in the previous chapter. So let me show you the idea here. So yes, I want to find out the area between these 2 functions. So let's say first, how did you find out the area under the f function? So let's say I have one more time the same image. So to find out the area between a and b, we used to create many infinite number of the rectangular under the curve. Do you remember that? So that by thinking about the Riemann sum, so that you are adding all the summation of the Riemann sum, we are able to find out the area. So this is, let's say, the same idea Riemann sum. Let's say you have many infinite number of the, rectangular. And then I'm going to create the second function. Second function, let's say we have here, g function, correct? And then we are looking for the area same between a and b. To find out this area, I know you're going to create the same many number of the rectangular, isn't it? So what if you subtract, from this area, this yellow area under the f function, minus the area under the g function? What happened? Exactly, you're going to find out the between function. Does it make sense? So because of that simple geometric idea, if you subtract the large, this is a little longer rectangular, and then you subtract a little bit of short rectangular every time between a and b, you're going to subtract many times from the large length of the rectangular to the short length of the rectangular. You're going to have exactly the between, right? The between area, 2 function. Very understandable topic, right? So because of the reason, it's the same thing. The idea came from the Riemann sum, right? You have a many summation of the rectangular under the f function minus many infinite number of the rectangular's area under the g function. Subtract, you're going to find out the area that we are looking for between area. So therefore, simply we're going to utilize f function minus g function, take the integral from a to b because they are going to be exactly between a and b. Okay, so we're going to utilize this, idea to find out the area between functions. So the thing is, before you're going to utilize this integral, always remember, find out which one is going to be the f function, which one is going to be the g function. You will be given 2 different functions. Check it out, which one has a higher height, which one has a short height, so that you can define which one is f and g. Okay, so let me show you the example. It's a lovely topic, so we can take a look at the following question. Okay, here we go. So we're going to take a look at this question. Determine the area between 2 functions. So you see that they don't tell you which one is f and g. They just tell you, hey, there are 2 functions. One is e to the x, another one is y to the x. We know that this isn't simply linear function. This is an exponential function. So you need to define which one is f and g. So fx, we're going to subtract gx by taking the integral a to b. This is the between area, correct? So you need to find out which one has a higher height. And then they say exactly between 0 and 1. Here is the image. So when you have 1, or let's say this is 1, when x equal to 1, we know that this is y equal to x linear. This is y equal to e to the x. So when x equal to 1, what happened? Y equal to ex is higher than y equal to x function. You see that you can simply compare the height when x equal to 1. So y equal to ex is this amount, but y equal to x is only that amount. So therefore, y equal to e to the x, this is going to be the f function, because f function should be higher height, and then this is going to be g function. So we got it. Which one? You're going to subtract from where? And then definitely they have a 0 to 1. We are looking for the area between 0 and 1 right there. We're looking for that area. Okay. So we got it. So we can set it up. So we know the formula right there. I'm going to just copy this one more time. So the between area is going to be f minus g. And then we know every information from 0 to 1. Now f is going to be e to the x. G is going to be the x and dx. So we are going to take the integral with this subtraction. I'm going to do the separate. So 0 to 1, e to the x dx minus 0 to 1, x dx. So then we are going to take the integral. So remember, whenever you take the derivative or integral of e to the x, they are going to be the same thing. So e to the x, same, 0 to 1, and x 2 over 2, because there's an invisible 1, and from 0 to 1. So we're going to subtract e to the 1 minus e to the 0 minus 1 over 2 minus 0 over 2. So this is going to be e. This is going to be 1. E to the 0 is going to be 1. That guy is going to be 0 and minus 1 over 2. So if you subtract these two, you can find out the common denominator, which is a 2, and then e minus 3 over 2 you will get. You can convert it to the decimal by using decimal. So it's going to be about 1.22. So this is area between two function, e to the x and x. That's how you're finding area between two curves. Okay, so that's the example. Okay, the concept, it's very simple, right? I mean, I don't want to say simple, but we are utilizing the benefit of the integral. It helps us to find out the area, but not only for the the area under the one function. You can also find out the area under the two function, between area. So therefore, the idea is a large area minus a smaller area. You will find out the between area. You're gonna be asked all the time to find out the between area in 2.1. Okay, so we're gonna keep practicing it, because I want to help you which one is gonna be f and g. You need to define which one is a higher and short height. So let's take a look at number 2. Here we go. So same question. We are looking for the region, bounded above by the graph of the function. So there are two functions as a given. One is f is x plus 4. Another one is g 3 minus x minus. So we need to check fx height is greater than g of x. So let's check it out. So definitely this is, both of them are linear function. And then this is a increasing. So this is going to be y equal to x plus 4. And the bottom is y equal to 3 minus x over 2. So let's check it out. When x equal to 2, definitely the height of the f function is higher. So we can exactly utilize f minus g function, right? So I'm going to just copy. We know this. Then copy here. And then they say between 1 and 2, find out the area. So between 1 is going to be around here, every 2 units. So we are looking for the area 1, 2, 4. So this is area we are looking for. So let's set up that equation. So we check that f is higher. So 1 to 4, f is gonna be x plus 4 minus 3 minus x over 2. This is f and g. We are going to take the integral. So if you want, we can do the distributive property. So let me just minimize, and that it is equal to 1, 4, x plus 4 minus 3, double negative change it to positive x over 2 dx. Are we okay? So you can do the combining like term, number family, x family. So just so you know, x plus x over 2, this is a 3x over 2, isn't it? Because x you can say same as a 2x over 2, common denominator. So that it is same as 1 to 4, 4 minus 3 is 1, x plus x over 2, 3x over 2, and then you are going to take the integral still. I'm going to separate it, 1, 4, 1 dx, 1, 4, 3x over 2 dx. I'm going to just minimize a little bit so that it is going to be x from 1 to 4. You took the integral, and I'm going to bring 3 over 2 to the front, x 1 plus 1 over 2 from 1 to 4. So if you subtract, so this is going to be, I'm going to just bring here. So it's going to be 4 minus 1, correct? Plus 3 over 2. We have x to the second over 2 from 1 to 4. So it is going to be 3 plus 3 over 2. You're going to plug in 4, 16 over 2 minus 3 over 2, 1, 1 over 2. So I'm plugging in 4 and 1 for each, right? And then if you calculate it, what happened? 3 plus 16 times 3, 48 over 4 minus 3 over 4. So anyway, if you calculate that, I'm going to just try all the little bit left side. So if you calculated 3 plus 45 over 3, am I correct? So you can adding them and then change it to the decimal, about 14.25. That's the area between two curves. Beautiful. Okay, so just you need to keep, making sure which one is f and g. Once you set up, that equation, taking integral is not that difficult, right? So just show us step-by-step work and you're good to go. Okay, so that's a second example. I hope this is getting better and better. Okay, I'm gonna keep showing you with a little bit complicated function, right? So we're gonna keep practicing. Let's go to example 3. So here, I'm gonna make more space. Example 3. So we're gonna find out the area between those two functions. So one is definitely quadratic function. So I know this green is gonna be 9 minus x over 2 to the second. And then the purple, this one is gonna be the linear 6 minus x. They're looking for the area between two functions. So that is going to be exactly this area, right? So this is the area we are looking for. But hold on. Do we know the range? From where to where? So if we do not have the range, you need to find out that range. It's going to be the intersected point between two functions. So this is going to be your A. That is going to be your B, because we are looking for between two functions. So we are going to first check the f function height is higher than g function. So when you have a 0, just look at any random point, 0. So the green is higher than, purple. So definitely quadratic height is always higher than the purple. So we good. So do we know A to B? No. So we don't know. So therefore, we're going to find the intersected points between two functions. Where? How are we going to find out the intersected point? This is the point where f of x is equal to g of x. So that's how you're going to find out a and b. One more time. We're going to find out the a and b. That's the intersected point, correct, between two functions. So to find out a and b, you're going to set up f function is equal to g function so that you're going to find out a and b. So let's find out that. So I'm going to just highlight this. So f function is 9 minus, I'm going to expand it, x second over 4, that is equal to 6 minus x. So we are solved for x. Beautiful. Now, how are we going to do it? Let's get rid of the denominator 4 by multiply 4 everywhere. So I know you're going to how to calculate multiply 4 to each term. So then it is going to be 36 minus x second, 24 minus 4x. So we are still solving for x. Let me minimize it a little bit. And then I'm going to move negative x second, move 4 to the other side, positive 4x. And then 36 minus 24. I'm just subtracting the order. Plus 36 minus 24 equal to 0. So negative x second plus 4x plus 12 equal to 0. Let's divide it by -1 everywhere because I don't like negative in front of the x second power. So it's the same as x second minus x minus 12 equal to 0. Are we okay? Now, what do you feel? How to solve the x? Ooh, binomial factor. So x, if you have 6 and 2, and then this one should be positive and negative. So here, x minus 6 equal to 0, x plus 2 equal to 0. So we have two x's. One is a positive x, one is a negative 2. So this is your x's where those two functions are meeting with each other. So what do you think? Exactly, a is going to be -2. 6 is going to be the 6. B is going to be the 6. So that's where we are looking for from -2 to 6. So we found out the intersected point where the f function and g function are equal to each other. Now you can set up that equation, the between area, right? So this is the between area function. So now we have from where to where? -2 to 6. And we confirm that f function is higher. So 9 minus x to the 4 minus g 6 minus x dx. So we are solving this. You got it. Let's expand. So -2 to 6, 9 minus x second over 4. You're going to do the distributive property, -x plus x dx. I don't need a parenthesis anymore, so I'm going to get rid of it. So that's what happened. If you want, you can combining like term. So it is going to be -2 to 6 minus x to the second over 4 first plus x 9 minus 6 plus 3 dx. Okay, we are taking the integral. Let's separate them. So -2 to 6, negative first, negative x second over 4 dx, -2 to 6 x dx, -2 to 6, 3 dx. Better and better. So I'm going to bring the number -1 over 4 in front of the integral. So you're taking x to the second. And then this one, x to the invisible 1 plus 1, 2 over 2 from -2 to 6. This is a 3x, -2 to 6. So this is -1 over 4, x to the third over 3 from -2 to 6. And then you can simply subtract them, but I'm going to just copy this one more time. So that's what happened. So this is negative 1 over 4, 6 to the third over 3 minus negative 2 to the third over 3 plus 6 to the second over 2 minus negative 2 to the second over 2. Because we are subtract, right, from the 6 minus 2, plus 3 times the 6 minus 3 times the negative 2. So that's what you're going to calculate it. So 1 or negative 1 over 4. What is a 6 times the 6 times 6? 2, 1, 6 over 3. And then minus negative times negative, negative 8 over 3. And then 36 over 2 minus 4 over 2. We have 18, double negative change to positive. We good. Now what happened? Negative 1 over 4, right? You're adding them, it's a double negative change to positive. So 216 plus 8 over 3. So think it's, same common denominator. So 32 over 2. This is a 24. So if you keep simplifying, what happened? 216, so this is a negative. If you adding negative 1 over 4, 2 to 4 over 3. This is going to be 16, 24. Again, you can convert it to the decimal by using your calculator. So I'm going to convert it to the decimal using calculator at this point because we simplified everything. 21.33. So this is the area between the curve, the green area we are looking for. Are you okay with that? So in this question, the A and B, the interval was not given. So therefore, we know which area we are looking for. So you're going to find out the intersected point where the f and g functions are equal to each other. Does it make sense? So you're going to find out the A and B, then keep going, keep taking the integral. Okay. So that's pretty much you're working on, finding the area between curves. Okay. So I'm going to keep showing you more complicated functions. So two things you need to check. Which one is a higher, f and g? Check it out. F is higher than g. Second, the interval if that does not given, then find out. Okay. All right. So I'm going to do two more examples. Ready. Here we go. So example 4, find the area, the region between. So this is two functions given. One is the radical, one is the rational function. So y equal to radical x is the green one. So y equal to radical x, and the purple one is y equal to 1 over x. I want to know, f is higher. So the green one, whenever you have 2, 3, 4, green is always higher. So we know that this is f. This is a g. So f of x is higher than g, we check. And then they exactly talk about the between, where to where, here, 1 to 4. So we are looking for this area. This area. Okay. So what are you guys going to do? So this is so clear. The radical x is higher than 1 over x, because if it is a 2, green is higher than the purple. So you have that relationship. So therefore, 1 to 4, what is f? Radical x minus 1 over x dx. 1 over 4, I'm going to separate it, x dx minus 1 over 4, 1 over x dx. Good. So now we are going to take the integral. So we know what the radical means, half exponent, isn't it? So therefore, 1 to 4, x to the half exponent minus, and 1 over x is a x to the negative exponent. I'm going to change that way. So just, the x to the radical, x is x to the second half exponent. And 1 over x is x to the negative 1. So I'm just change it to the exponent. So now it's better to take the integral, right? So what happened? This guy, x 1 over 2 plus 1 over 3 over 2 from 1 to 4. And then be careful. Do you remember? This is very, very unique when you take the integral 1 over x, right? So if you take the 1 over x, it is going to be ln x. Do you remember? Ln x absolute value from 1 to 4. So therefore, I'm going to simplify. You can flip over. So 2 over 3, x to the 3 over 2 from 1 to 4. And then this one, we know ln 4. I need a space. So let me make a little bit of space. So ln 4, absolute value 4, ln 1. But it's going to be positive number. So I can simply, I'm going to minimize again. So what I'm saying is, you're going to have ln 4 minus ln 1. Right? So then we're going to keep simplifying. This means 2 over 3, 4, 3 over 2, 1, 3 over 2. And then this is going to be ln 1 is a 0. So we have a negative ln 4. Okay, so we're going to keep simplifying this part, right? 4 to the 3 over 2. 4 is a 2 to the second to the 3 over 2. So 2 top bottom 2 is going to be cancelled. So 2 over 3, we have a 2 to the third remaining only. And then 1, whatever exponent is 1, minus ln 4. So that means 2 over 3, we have 8 minus 1 minus ln 4. So the most simplified answer, 3 over 7 times 7 minus ln 4. Now you're going to use a decimal or your calculator, convert it to the decimal, 3.28. This is the area. So you need to be careful when you're taking the integral, what's happening, then it's going to be same, answer. You will find out. All right, so this question, we killed it. We good. Okay, we are doing an awesome job. You guys doing awesome. All right, so let me keep going. The next question. I'm pretty sure you're gaining a better confidence. So let's take a look at the bottom question. Here we go. Ooh, what is going on? So we are looking for the area. Ooh, we have a couple function. We have a y equal to x cosine x, y equal to 4x, x equal to pi over 4, x equal to 3 pi over 4. So we have 4 different functions are going on. So let's look at it. So y equal to sine x is going to be the green one. This is a trigonometric function. So I do know this is y equal to sine x. Y equal to 4x, this is a linear. So the purple one is going to be the y equal to 4x function. And then remember x equal to pi over 4, x equal to 3 pi over 4. This is a vertical. Do you remember? X equal to 2, graph it. It's going to be the vertical. Graph it, y equal to 2. It's a horizontal line. So x equal to pi over 4, actually we already here. So this is, one is x equal to pi over 4. Another one, x equal to 3 pi over 4. So that's the 2 vertical line. And then if you highlight all the area that are surrounded by those 4, right? Where is it? Right there. We are looking for this area. Are you okay? So what happened? This is actually a and b, your range between a and b, and you're looking for the function between y equal to 4x and y equal to sine x. And then what happened? Which one is higher? Between these two, the purple one always higher than the trigonometric function. So we know that is going to be your f of x. This is going to be your gx. So let's set up that equation. So we check fx should be minus a gx. So we know which one is f. So therefore, from pi over 4 to 3 pi over 4. F is 4x. And then g is a sine x. We are subtracting that and taking the integral. And then it means pi over 4, 3 pi over 4, 4x dx minus pi over 4, 3 pi over 4, sine x dx. That's what we are doing. Are you following? So analyze what the given and which area we are looking for. Each function has a role. So one is f and g, another one is a and b. So you can set up that equation. The rest of work, taking an integral. So the first equation, I'm going to bring 4 to the front. So 4 pi over 4, 3 pi over 4, x dx. And then if you take the integral of the sine x, we know what it is. It is going to be negative cosine x from pi over 4, 3 pi over 4. Got you? And then we also need to take the integral x to the second over 2, pi over 4, 3 pi over 4, double negative change to positive, pi over 4, 3 pi over 4. Okay, we're going to keep simplifying. This is going to be 4 divided by 2, x second from pi over 4, 3 pi over 4, cosine x, pi over 4, 3 pi over 4. You are doing good, and now we're going to do the subtraction. 2 times 3 pi over 4 second minus 2 times pi over 4 second. So that's the first term. And then second, cosine 3 pi over 4 minus cosine pi over 4. So now you're going to keep simplifying. So let me minimize it a little bit. Okay, here, and I need to bring that pi. Actually, let me rewrite it. There's a 3 pi. So this one, 2 times 9 pi second over 16. 2 times pi second over 16. Okay, and then this one, cosine, keep it. And then cosine pi over 4. So this is pretty much, we can simplify as much as we can. Actually, if I just recalculate this part, this one is going to, if you calculate this one, 18 minus 2 is a 16. So these two fraction, if you subtract, you will get just pi second. So I'm going to rewrite it, pi second minus distributive property, cosine 3 pi over 4, double positive, cosine pi over 4. So now you can convert it to the decimal, because in your using your calculator or decimal, so that this is your simplified answer. And then as a decimal, it would be around 8.455. So that's your answer for example 5. Better? Better. Okay, you good. All right, so I'm gonna do a couple more. Hang in there, a couple more. The more you do, the better you have, right? So let's keep going. 2 more. So I'm pretty sure this is okay with you. Okay, example 6. So this is what we have. Okay, we're gonna find out the area between 2 functions. It's a very unique, but as I mentioned, y equal to whatever number, it's gonna be the horizontal line. Do you remember? So if you graph it, exactly this is y equal to 1. And then green one is y equal to x second minus 3. We are looking for the area between these two. Right? Because that's the between area, but you need to think about it. This is a very, very interesting. So determine the area, the region bounded, one is y equal to x second minus 3 and y equal to 1. So actually, it's actually entire here. The between these two is this area. So my bad. So this is the between area. Above the quadratic function, below the y equal to 1, that's your between area. Am I correct? Okay, so that's all they gave us. That's all you have. Do I have the range? No, I don't know where is A and B. So to find out A, B, you're going to find out the intersected point. Where? How to find out? Fx equal to gx. So these two are intersected point. A, this is going to be B. So wait, did we check which one is F and G? So whatever you have, any point between A and B, purple is always higher than green one, right? So therefore, purple is going to be your F function, and this quadratic will be your G function. So now you're going to set it up because F must be higher. So the area, we need to find out the intersected point first. So to find out, x second minus 3 equal to 1. So that means x to the second, you're going to solve equal to 4. So x is going to be plus minus 2. Gotcha. A is a negative 2, B is a positive 2. So now you can set up that equation. So we found out the intersected. So from negative to positive 2, which one is F? 1 minus G. This is F. This is F. This is F and G. This is your equation between area. So therefore, if I rewrite it, negative 2 to 1 minus distributive property negative x second, positive 3 dx. Again, negative 2 and 2 minus x second, 1 plus 3, 4 dx. Now I'm going to separate it, negative 2 to minus x second dx plus negative 2, 4 dx. Gotcha. All right. So we are taking the integral, this guy, negative, I'm going to bring it into the front. So x to the third over 3 from negative 2 and 2. This is a 4x from negative 2 and 2. Okay, we are doing awesome. So that means what? Negative 2 to the third over 3 minus, and then we're going to subtract again, negative 2 to the third over 3. So this is the first one. So let me make it a little, I'm going to make a little bit smaller, right? And then you adding the next one, 4 times 2 minus 4 times negative 2. Oh, I need a little bit space more. So that's actually what happened. Are you okay? Yes, so we're going to calculate it. This is negative 8 over 3, and then double negative change to positive, and then we have another negative 8 over 3. Am I correct? And then that's the first part, and then 8 double negative change to positive, this. So you're going to calculate this too, negative 16 over 3 plus 16. So you can now convert it to the decimal around 10.67. So that's the area of the green one. How you feel? How you like that? You like that? Okay. So I'm pretty sure it's the same strategy. We are all going over and over and over and again. I'm telling you, let's do the final question. A little bit complicated case. Okay. So let me introduce that question 7. Okay. So in this question, we know what's going on. We're going to find out the area between two functions. So one is, it's a very, very long. It's a polynomial, y equal to x to the third minus 4x second minus x plus 4. So this is really polynomial. So the green one, right? The green one will be x to the third minus 4x to the second, x plus 4. The polynomial function. So this is the polynomial, poly, right? And then we are looking, and they say another function is x-axis. Where's the x-axis? This one. The x-axis is right there. Okay, the x-axis. So the function between two, purple and, you know, the blue, it's a little bit here. So there might be mentioning the area between function, this one, right? This is the between purple and blue, and then the bottom one. And then they actually say from -1 to, so -1 is right here. X equal to -1. This is x equal to 3. So they have a two between area. Where to where? This one. So we have the between area up and down, right? Because exactly this is the area between two function and from -1 to 3. So I'm gonna say, make sure the above area A1, the below area 2. So the total between area, it's going to be A1 plus A2. So we have to set up that integral. Okay, so here is one thing. You should find out this intersected point. This is the intersected point, two functions. So how to find out the all x-intercept? So do you have actually 3 x-intercept, right? These are 3 x-intercept where f and g functions are equal. So what we're gonna do, we're gonna make it equal to same. So to find intersected points, we're gonna say fx equal to gx. Okay, so here f and gx, it's a little bit complicated. In A1, right, the purple is always higher, but A2, the x-axis is always higher. So that's why we are separating two different areas. Does it make sense? So first step, let's find out all the intersected point first. So I'm gonna say x to the third minus 4x to the second, x plus 4 equal to 0. That's the x-axis, y equal to 0. So if you remember from pre-calculus, this is a 4 term, you're gonna make a group factoring. So first 2 terms, second 2 term, they might have some commonality. So I'm gonna find out the factor between 2 terms, x second, x minus 4, and then minus is a common factor, x minus 4 equal to 0. So now you have a common factor, x minus 4, and the remaining x second minus 1 equal to 0. So this means x minus 1, x plus 1, x minus 1 equal to 0. So that you have a 3 x-intercept, x equal to 4, x equal to -1, x equal to 1. So these are your x-intercept. Exactly here, x equal to 1, -1. This is x equal to +1. This is exactly x equal to 4, right? But we are looking for between -1 and 3. So we just double check all the x-intercept. So let's find out the A1 area. Okay, A1 area is from -1 to 1. And in this area, the purple polynomial is always higher than x-axis, correct? So you're gonna subtract x to the third minus 4x to the second, x plus 4 minus 0, right? That's f minus 0. And take the dx. And then A2 area, it's from where to where? From here to stop +3. We are not going for the stop 3. From 1 to 3, but in this time, the y equal to 0, the x-axis is higher than purple one, so 0 minus the second function. In this time, the polynomial will be 0. So you see the difference? Okay, so here, in the first area, I'm gonna write the same color. So the first area, polynomial function was higher than y equal to x-axis, right? But the second area, x-axis higher, height is higher than poly. So that's why you have to subtract from 0 minus that, because that's in this case f, this is gonna be g. In the first area, this is your f and this is a g. So that's something you need to be careful. Okay? So make sure that's important. And then whatever you're finishing integral, you're adding those two areas to find out the total area. So let's find out A1 first. So A1, I'm gonna just take the integral, x to the 4 over 4 minus 4 x to the third over 3 minus x second over 2 plus 4. 0 is a 0, and from negative 1 and 1. So if you calculate it, f1 minus f negative 1. So this is a 1 over 4, 4 over 3, 1 over 2 plus 1 minus negative 1 to the 4 is a positive 1. And then negative 1 to the third is a negative. So negative 1 times negative 4, positive 4 over 3. And then negative 1 to the second positive and minus 1 over 3 plus 4. So you can calculate that. And then everything is cancel. So negative 1 over 2, negative, positive 1 over 2 cancel. And then plus, what else are we going to cancel? 1 over 4, negative 1 over 4 cancel. So we have negative 4 over 3 minus 4 over 3, negative 8 over 3. And 1 minus 4 is a negative 3. Yes, you're going to get it. So let me double check. 4x. So I have a little bit of typo. When you take the integral, I forgot one thing. Sorry. So let me just bring here. We forgot x here, right? Because when you take the integral, it's going to be 4x. So 4 times x is going to be 4. 4 times negative 1 is going to be negative 4. So that's my mistake. Okay. So again, 4 minus 4, positive 8. So if you calculate it, 5.33, this is A1 area. You can calculate again on your piece of paper, A1 area, you will get that number. And then A2 area. A2, we're going to do 1, 3, and then everything distributive property, because we subtract from 0, minus x to the third, plus 4x to the second, plus x minus 4, dx. So you're going to take the integral, minus x fourth over 4, 4x to third over 3, x second over 2, minus 4x from 1 to 3. So 3 minus 1. So minus 3 to the 4, you're going to calculate at 81. And then that is going to be negative 81 over 4. 4 times the 3 to the 3, 27 times the 4, 108 over 3, 9 over 2, 12. This one minus when x is 1. So negative 1 over 4, 4 over 3, 1 over 2, 4. Okay, so you're going to calculate all the decimal. So negative 81 over 4, 108, 9 over 2. So do all the distributive one more time, 1 over 4, 4 over 3, minus 1 over 2, plus 4. So you're going to combining like term as much as you can. And then please calculate it using your calculator or decimal, try that. It should be around 52.16. So this is A2 area. Are you done? Nope, you're going to adding those two. So A1 plus A2, 5.33 plus 52.16. Around 55.40 now. We are approximating. This is not perfect answer, but we are approximating always. Integral help us to find out approximate area. So that's your area between the curve from A1 and A2. Okay, so that's your final answer we got. Does it make sense? So hope last example, it makes sense to you. And then 2.1 is a little bit long topic. I'm going to make a second video. And then we're going to finish entire 2.1 very soon. Anyway, I will stop recording at this moment. Okay. And then I will see you in the next video, part 2 of 2.1. Okay. See you soon, everyone. Thank you.